Okay, this lesson goes with a worksheet called Sawtooth Worksheet. And basically, we have functions, and we're going to be either stretching them left, right, or up, down. We're going to be moving them. And the ones that are complicated, the R3 level kind, is the kind that where you do absolute value of functions. All right, so watch what happens. First of all, the function here, f of x, is this like Dracula sort of themed m. All right, so there's my original. If I did this to it, what would that do to it? Would it make it wider, narrower, taller, shorter? What is it? Narrower. Doesn't it seems like it should be twice as wide? So it's actually what? Half as wide. All right, so it should actually be the same height, but half as wide. Go ahead and sketch what you think that should look like. Sometimes it helps to sketch it on the same exact graph, just with like a different line, like make it lighter or squiggly lines or something. Well, basically, all you really have to do is take each point of it, the important points, and move them. Like, here's what I'd say the important points of this are. And if I take each of those points and I move them to a new spot that's half as wide as it was, I'm going to take this spot here and move it over here. This spot here and move it over here. This spot here, I'm going to move it halfway to the origin. This spot here, I'm going to move it halfway. Oh, wait, that one doesn't move anywhere. I'd be starting to move it up, and that's not good. I'm supposed to only move left, right. This one goes here. This one goes here. And this one goes here. And then I just get to connect the dots. So it's still kind of a Dracula M, but it's narrower. You get what I just did there? All right, so that's why I was saying this stuff's pretty easy. I'm going to undo that now and go back to a nice normal M here. And let's say I did this to it. 3f of x. What would that do? Don't have to even do it. Just tell me. What would it do? 3 times taller. But here's the thing people do. They go, okay, so I make this go up 3 times as tall. And then I make this thing move up. Do you get what they're thinking when they do that? Is it right? No. Because it's not only 3 times taller, it goes down 3 times as far. You get what I'm saying? So yeah, this part needs to go up 3 times as tall, but this spot that was down, however far it is from the origin, needs to go down 3 times as far. So it goes way down here. Okay? So this spot is 3 times as high as that. This spot is 3 times as high as that. This spot doesn't move because it's an up-down thing. And this spot right here went down 3 times as low as it was. All right. So again, backing off on here. Now, the harder kind, this is where you really need to pay attention, is when you do absolute values of things. All right, if I do f of x, and I do the absolute value around it, did I just put absolute values around the x's or the y's? Just think about this. The y's, because isn't f of x the same thing as y? So I just put absolute values around that, so I just put absolute values around the y's. The y's are negative down here. But I just put the absolute value of them. That's going to turn all my y values into positive numbers. If they were like this one right here, negative 2, for instance, is going to become what? Positive 2. And so my new graph, this would still be the same, but they won't go down there because it won't go into the negatives. This will turn everything into the positive of it, so it's going to make it bounce up. And that stays the same, and that stays the same. My final answer would be the black graph. See what I get? How I got that? Okay, so when you do the absolute value of the y's, this part bounces up. All right. The next part is where you're going to, like the only complicated thing for the day. And that is when you do the absolute value around the x part. Because what that does is it takes my function, here I'm going to clear this off so I can get my m back again. If I put my absolute values not on the outside here, if I put them inside, then here's the first thing is, do you get that when I did the absolute value of x that my x's can't be negative anymore? So that means this side of the graph over here has to somehow be different? Okay, but it's more complicated than just wiping that off. And some of you might think, well, you can just reflect what's over there, just like we did the last time where we kind of reflected this part up and we made it like go like this. Maybe you're thinking you can just take this part and like reflect it over there. That's not it though. That's not what you do. All right, here's an example of one where my original function is just f of x, and this is the original function. First of all, is it a function? Yeah, it passes the vertical line test, so it's a function. But if I want to do this to it, here's what you'd do. The absolute value, as soon as you put the absolute value on the x, that means when I put in an x that's like -2, it would not give me this part anymore. Because if I had x become -2, my function is going to think I put in a what? A 2. So it's going to go over here and say, oh, well, when you put in a 2, you're supposed to get that. And so when I put in a -2, it's going to put out, oh, -2 is over here. It's going to put out that. And when I put in a -3, it's going to think, oh, that's like a +3. So it's going to put out that, which is like this. And it ends up being my final answer is that the part that was on the right-hand side stays exactly the way it was. And the part that was on the left-hand side disappears and gets replaced with a reflection of the right-hand side. So my final answer is this whole thing right here. All right, I want you to try one. Let's say I had this picture. I want you to sketch this picture. Sketch that picture. It goes down low, but then it goes up about twice as high as it does down low. And say that's f of x. Then what would f of absolute value of x be with the absolute value on the x parts? See if you can draw the right picture for this. All right, first, do you get that the left-hand side can't exist the way it used to exist? This part right here needs to go away. Do you get that? Because now whenever I put in a number like that's negative, like -5, for instance, let's say this is at 5, it's going to think I put in a +5, and it'll give me an answer of, in this case, 0. So this spot will get reflected from there over to here. And if I, for instance, put in, it looks to me like this is right above the 3 on my little picture, and so therefore, if I put in a -3 here, it's going to think I put in a 3. So that's effectively going to mean that this whole part gets reflected over. It's your final answer. It kind of looks like the McDonald's M. Raise your hand if you had that right on your paper. Good. All right. Then I got across the only thing that's hard on the worksheet for today. Okay? Because most of them are like, this is really tough. You mean I got to make it half as wide? Ooh, that's really hard. Or what does that do? Twice as wide. What if I do that and this? Twice as wide and down 3. And which should be done first? First you make it twice as wide, and then you move it down 3. Okay? All right. And remember, when you're doing those, these are quite different. Now on this one, that takes all the y's and makes them bounce up. So again, there can't be anything down here. Your whole graph will be like up here. And this makes whatever was on the left-hand side disappear. And so in this case, it would make this disappear. And it would take whatever is over here, leave it there, and reflect it over here. Final answer is this really dark green